Yo, welcome back. This is me again, and I'm gonna do diagrammatic representations of more complex molecules, complex molecules, complex molecules, complex molecules. Okay. So first we're gonna talk about nitrogen as an element. All right, elemental nitrogen, which is basically nitrogen gas. And its formula is N2. That means for each molecule of nitrogen, there are two nitrogen atoms, boom, combined together in a covalent bond. And how are you going to represent this? Well, wipe. First, we need to draw the valence electrons for nitrogen, each nitrogen. The first nitrogen, I am going to represent it as a dot. On the second nitrogen, I am going to represent the second nitrogen atom with valence electrons that is represented as crosses. Now, here comes the jigsaw puzzle part. What you need to do here is to link up between a cross and a dot so you can start visualizing how these electrons are shared. Alright, so you know that a pair of electrons by two different atoms represents one covalent bond. One covalent bond. So that's one covalent bond. That's another covalent bond. And you have another covalent bond like so. Now we just got to make it pretty. So we understand that nitrogen, in order to combine to form nitrogen gas, it will share 3 electrons that it has entirely with another nitrogen atom. All right? And so those two nitrogens will ultimately share or have 6 electrons together. And they're going to share those 6 electrons. All right. So how are we going to make this look pretty? All right, scooty-doo-doo. First, we draw a circle to represent the nitrogen valent shell. All right, we're gonna draw in that these unbonded electron pairs on their respective nitrogen atoms. Okay, so one with a circle and the other with an X. And in between here is where we're going to put those 6 electrons. So 3 dots and 3 X's or crosses. Dot, cross, dot, cross, dot, cross. There you go. And so this is kind of like the diagram that you should be able to create on your own. All right? Although in real life it doesn't really look like this. But anyway, this is what your curriculum is content with. Moving on. Let's talk about an organic molecule called Athene. All right? And Athene has a formula of CH3OH. How are we going to do that? Well, since C is written up in front like so, you can essentially understand that it's going to be the 2 central atoms. Why? Because each hydrogen can only form 1 bond. And if you put hydrogen as the central atom and C is around it to form bonds, that's not going to happen because hydrogen can only form 1 bond. All right, so the carbon atoms are going to be the central atoms. So carbon here undergoes and has 4 valence electrons each. Okay? And each hydrogen has 1 valence electron. All right. Now we're just going to try to link up and see the bonds that's going to be formed. So I'm going to assume that this is going to form a bond and that's going to form a bond. And maybe this is going to form a bond and that's going to form a bond. Alright? So what we're left with is that these two electrons are going to form a bond. And you have these two pairs that need to do something. They can't bond with hydrogen anymore because hydrogen is bonded with something else. So it will have to form another bond with itself. The carbon will have to form another bond with another carbon atom. Alright, in that case, what we have here is a double bond because we have a double bond now. A double bond. Okay? So, how are you going to make this look pretty? Draw a big circle to represent the carbons. The carbons in here have dots, right? So they're going to share, the two carbons are going to share 4 electrons. So dots, 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 and dots. Okay? You have 2 hydrogens connected to each carbon. And I'm going to do the other one. Now, the carbon's electron will be a dot, and the hydrogen's electron will be a cross. And there you have it, the molecule of Athene. Now, whenever you're done with your work, you should check it. Alright? So, you've got to check it for its noble gas configuration. Let's look at hydrogen. Let's look at this hydrogen. This hydrogen here. How many electrons does that hydrogen have? Well, if you look around it, it has 1 electron and 2 electrons. So it has noble gas configuration. Oh, how nice. Let's look at the carbon. Carbon has 1 electron, 2 electrons, 3 electrons, 4 electrons, 5, 6, 7, 8. So carbon has 8 electrons, so it is also content. It has a low energy state compared to the individual atoms. Alright, moving on. Let's do methanol. Methanol has a formula of CH3OH. It's an organic molecule. Cool. Alright. And the way that these formula is written out gives you an idea what kind of bond, what is bonded to what. Alright. If you look at hydrogen, it's right after carbon. So these 3 hydrogens has to be connected to this carbon. Alright. So you have carbon, and each of them is going to be connected to a hydrogen. Alright, it's going to get connected. Carbon has that 1 valence electrons left, and what is it going to be combined to? Well, if you look at what's next, it's oxygen. So oxygen is going to be here. And how many valence electrons does oxygen have? 6. Alright, I'm going to represent the electrons for oxygen as triangles. Okay, and this is going to form a bond. Wonderful. And so you only have 1 electron left that's not bonded. Okay? And if you look behind oxygen, there's hydrogen. Hydrogen is here. And hydrogen has the electron represented as an X across. And so that's going to form a bond. Wonderful. So that's how it's going to be like. Let's make it into a IGCSE acceptable model. Well, here we go. You have a big circle running out of black ink right there. So that's carbon bonded with 3 hydrogens. All right? So it's a dot and cross, a dot and cross, dot and cross. Carbon is now connected to oxygen. So another big circle, that's my oxygen. They have one bond, which is a single covalent bond. And don't forget to draw the non-bonding electrons. Alright? And finally, you have your last hydrogen. And it's a cross and a triangle. There you go. And then, of course, you do your checks. And it checks out that all of them has their noble gas configuration. Cool. Finally, we have our carbon dioxide. All right. Formula for carbon dioxide is CO2. You should know this by now. If you don't know, okay. Carbon should be the central atom because it's written out in front. So I'm going to write it down like that. It has 4 valence electrons. Oxygen is on either sides of carbon because it's 2 and so it's combined there. Okay? Let's take a look. You can form 1 bond here, you can form 1 bond here, but you're left with 2 on carbon and 1 on each oxygen. Well, it turns out that the carbon will have 2 double bonds with 2 different oxygens. Whoa, pretty cool, ain't it? What happens when we do a diagrammatic representation? Draw a big circle to represent carbon. Draw 2 other circles to represent oxygens. And I'm going to use the dots to represent the electrons of carbon. And the crosses to represent the electrons of oxygen. And oxygen has 2 pairs of non-bonding electrons. And there you go. That's the diagram for carbon dioxide.